Welcome back to Advanced Skills Learning. Gen AI prototypes are easy. Production systems are hard. In this series, we focus on the decisions that determine whether your system actually works at scale. Today, we're diving into reranking, one of the most misunderstood components in RAG systems. Most teams treat retrieval as the main problem, but in reality, ranking quality often determines whether your answer is correct or completely wrong. Your retriever, usually a vector search, returns the top K results based on similarity. But similarity is not the same as relevance. This means your top results often include partially relevant or even misleading chunks. And here's the critical part: LLMs are highly sensitive to ordering. If the most relevant chunk is ranked third or fourth, the model may never use it effectively. Reranking exists to fix this gap between similar and actually useful. There are two main types of reranking models: bi-encoders and cross-encoders. They solve the same problem but in very different ways. Bi-encoders score query and documents separately, making them fast and scalable. Cross-encoders evaluate query and document together, making them slower but far more accurate. Understanding this trade-off is critical because choosing the wrong one can either slow your system to a crawl or silently degrade answer quality. Bi-encoders work by encoding the query and each document independently into vectors. These vectors are then compared using a similarity metric like cosine similarity. The key advantage is efficiency. Document embeddings can be pre-computed and stored, so scoring is extremely fast, even at large scale. But there's a limitation. Because the query and document are encoded separately, the model cannot deeply reason about their interaction. It's matching patterns, not truly understanding relevance. Bi-encoders are excellent for speed and scale. They're ideal for initial retrieval over millions of documents. However, they struggle with nuance. They may miss relationships like negation, context shifts, or multi-step reasoning within a document. For example, a document that mentions the same keywords but answers a different question may still rank highly. This is why relying only on bi-encoder retrieval often leads to almost correct answers, which are dangerous in production systems. Quick check. 2 seconds. How does a bi-encoder work? A. Bi-encoder compares query plus doc together. B. Bi-encoder encodes separately. C. Bi-encoder uses LLM. Keep your guess. The answer is B. Cross-encoders take a very different approach. Instead of encoding query and document separately, they process them together as a single input. This allows the model to attend across both sequences and understand their relationship in context. It can capture subtle signals like intent, contradiction, and precise answer alignment. The result is a much more accurate relevance score, but at a cost. Each query-document pair must be processed individually, making this approach computationally expensive. The strength of cross-encoders comes from joint attention. The model doesn't just see the query and document, it analyzes how they relate to each other at every token level. This enables deeper understanding. It can distinguish between similar-looking documents and identify which one truly answers the query. In practice, this often leads to significantly better ranking quality, especially for complex or ambiguous queries where simple similarity fails. The downside of cross-encoders is performance. They require evaluating every query document pair individually. If you retrieve 50 candidates, that means 50 forward passes through the model. This quickly becomes a bottleneck in production systems. So while cross-encoders deliver high precision, they are rarely used for full retrieval. Instead, they are typically applied as a second-stage reranker on a smaller candidate set. In real systems, you don't choose between bi-encoder and cross-encoder, you combine them. First, a bi-encoder retrieves a broad set of candidates quickly. Then, a cross-encoder re-ranks a smaller subset, say top 20 or 50, based on deeper understanding. Finally, only the top few documents are passed to the LLM. This hybrid approach balances speed and accuracy, and it's one of the most important patterns in production-grade RAG systems. Quick check. 2 seconds. What's the best production pattern? A. Cross-encoder for full retrieval. B. Bi-encoder only. C. Bi plus cross pipeline. Keep your guess. The answer is C. Many systems fail not because retrieval is bad, but because reranking is missing or misused. Some teams skip reranking entirely, trusting raw similarity scores. Others overuse cross-encoders, applying them too early and creating latency issues. Another common mistake is choosing the wrong candidate size for reranking. Too small, and you miss relevant documents. Too large, and your system slows down unnecessarily. These decisions directly impact both quality and performance. Let's summarize. Retrieval gives you candidates, but not necessarily the best answers. Bi-encoders are fast and scalable, making them ideal for initial retrieval. Cross-encoders are slower but far more precise, making them ideal for reranking. The key insight is not choosing one over the other, but combining them effectively. That's how you build systems that are both fast and accurate, systems that actually work. Thanks for watching. If this helped, like the video and subscribe to Advanced Skills Learning for more Gen AI explainers, practical architectures, and quick quizzes.